when we talk about inequalities, it's really going to be mostly review. There should be review. None of this should be new. This should all be things that you've seen before, but we want to set the groundwork for our very last lesson of this chapter. We're going to finish up inequalities, and then we'll be ready for our test next week. So we're going to talk about 4 different types of things in inequalities. The proper notation for an inequality, the proper notation for an interval, which sometimes because they both start with the letter I, those get a little confusing. How you would describe it in written word, and then how you would draw it on a number line. Again, this should be review, but we'll just lay the groundwork so that we're all talking about the same thing. So an inequality are the symbols greater than or less than. So when you want to write something in inequality notation, the first thing you would do is you would write it with those, when you were in elementary school, they call it the alligator, and the alligator is always facing the way it's facing the bigger things. It wants to eat the bigger part. That is inequality notation. When you switch to interval notation, the bar underneath is going to make a difference. It's going to matter. And so the way interval notation is written, it's written as with a comma, -1 and 4, like that. So it's starting at -1 and ending at 4. And then because the 4 has the line underneath it, greater than or less than or equal to 4, you put a bracket. So in interval notation, the bracket means it is equal to that number. And then when you don't want it to be equal to the number, you put a soft parenthesis. So that is interval notation. That's how you write that. You just keep the numbers in order with a comma, and then you put parentheses or brackets. If you're going to describe that in words, you might say something like this. The numbers between -1 and 4 and just saying that does not mean you're including either of them. The numbers between -1 and 4. That doesn't mean including -1 or 4, but we want to include 4. So then you would add and also including 4. So something like that. Okay, so the numbers between both of them, but also including 4, just not including -1. That might be how you would describe it. And then the last column is how to draw that on a number line. So our number lines are always centered at 0. And when we do -1 to 4, we're going to mark off -1, and 2, 1, 2, 3, 4, we'll mark off 4. And you'll put open circles, and you'll shade the value between. So that is the numbers between -1 and 4. And then how do we indicate that we want to include 4? Say it again. You fill it in, right. So one of these will be filled in, but the other won't. And so this means all the numbers between -1 and 4 and including 4. So that's how to take one problem and write it 4 different ways. So then let's go on. What if you start with just the words? The word positive reals. Okay, so let's suppose it's described that way. Well, let's do the number line first. All right, if we want positive reals, clearly we're going to start with a circle at 0, and we're going to go to the positive side. So that would be heading off to the right. Now, do we include 0? Is 0 a positive number? Is 0 a negative number? 0 is the only one that's neither positive nor negative. So if it's not including 0, so we want to make sure we leave it open because it only says positives. If they wanted to include 0, it would have to say positive reals and 0, or including 0 or something, but we're not including 0. So that's how you draw that on a number line. In interval notation, you would write it like this. 0, comma. Now 0 is the beginning. Where's the end? Infinity. And so you have to literally write the symbol for infinity. You can use 2 circles, or if you like to do a sideways 8, that'll work too. We are not including 0, and so it's a soft-sided parentheses because it's open. And we're not including 0 either. You can never, not including infinity. You can never include infinity. No one can ever get there, and so it would never be a hard bracket on infinity. So that's interval notation. And then for inequality notation, you're going to put 0 less than x, less than infinity, and neither of them will have the bars underneath because you're not including either of them. All right, the last one we're going to do is we're going to start with the number line. So I'll give you that, and then you rewrite it. So here's a number line marked off at 0, and we're going to have 3. Sometimes the number lines will be written like this. You'll have the bracket itself right on 3. Instead of a closed circle, it might be written like that. And then we're going to be shading to the left. All right, is that a greater than or a less than description? Less than. Okay, so all numbers less than what? Less than 3, including 3? All right, so then our words are going to be all numbers less than 3 and including 3. So when we write that in interval notation, 3 is the ending number because that's where the interval ends. And we put a hard bracket just like was drawn on the number line. What's the beginning number? What kind of infinity? Negative infinity. And you have to specify that it's negative. And we want to use a soft, because again, for infinity, no matter what kind of infinity it is, you're never going to have a bracket on infinity. And then for the inequality notation, you'll have negative infinity less than x less than 3, and then you want to go back and add the equal to bar under the 3 because that is the inclusive part. Does anybody have any questions about the different formats? So your homework, some of you looked ahead at your homework and you know that your homework is like, okay, here it is in interval notation, you do it this way, or here it is as a number line, you do it as words, or just transferring it back and forth. The last thing you're going to do with inequalities are some actual math problems. So you might be a little bit more comfortable. Again, it's solve. And when it's solve, we're working towards getting x by itself. And so you might have a problem that's like this. Solve the problem 3 parentheses x minus 1 plus 2 less than or equal to 5x plus 6. So then that becomes inequality for you to work towards getting x by itself. So my first step is going to be, we're not getting one side equal to 0 anymore, we're getting x alone. So we're going to distribute the 3, that'll give me 3x minus 3 plus 2 less than or equal to 5x plus 6. When I combine the like terms, I'll have 3x minus 1 less than or equal to 5x plus 6. What should I do to both sides? I'm just trying to get, just like a regular math problem, just because it has an inequality doesn't change it. What should I do to both sides? Okay, I need to combine like terms. So I've got a 3x on one side, I got a 5x on the other, I got a negative 1, I got a 6. What should I do first? I hear subtract 6. Okay, that could be one thing. Any other ideas? Subtract 3x. Okay, that could be something else to do. Anybody else? Okay, I could add 1, or I could subtract 5x. Okay, I'm going to go subtracting 5x because I like to have my x's all on this side. So that's going to give me negative 2x minus 1 less than or equal to 6. Now what should I do? It should be pretty obvious now. Add 1. So negative 2x less than or equal to 7. Now what? Divide by -2. What's the one rule you got to remember about inequalities? Okay, anytime there's a negative involved in either multiplication or division, you got to flip the sign around. So this becomes x now greater than or equal to -7/2, which is -3.5 or 3.5 as a decimal. So then we want to put that on our number line. All inequalities need to also be graphed. So -7 halves is -3.5. So here's -3, here's -4. So I'm going to put in a circle at about 3.5. It says x is greater than, so I need to shade to the right. So I'm going to the greater end. And because it was an equal to bar, I need to go back and fill in the circle to show that it's including the number -7/2. That should look familiar. You've done that before from Algebra 1 and Algebra 2. Okay, our last example, and then we're done till Friday. So we're going to solve one more. It's going to look like this. It's going to have -3 less than 2x plus 5 over 4 less than or equal to 5. So this is a little bit different. We call this a sandwich interval because it has a beginning and an end and a middle. But we still want to get x by itself. So if you focus just on the center part, and you want to, that's the only x that there is, you got to do something to all three parts, not just to 2, but to all 3. What should I do to all 3? Okay, multiply by 4. Do I have to flip any signs? I'm multiplying, so why don't I flip the sign? Not a negative number. All right, so I'm going to multiply everything by 4. So times by 4 times by 4. That's going to give me -12 less than 2x plus 5 less than or equal to 20. Okay, now what? Subtract 5 from the beginning and the end. So I will be subtracting 5 from the 20, and I will be subtracting 5 from the -12. That's going to give me -17 less than 2x less than or equal to 15. Then I divide. And I don't have to flip any signs again because I'm not worrying about a negative number. So I'll have -17/2 less than x, which is less than or equal to 15/2. So now we want to graph that on a number line. -17/2 is -8.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's -9, and so -17/2 would be about in the middle of there. Open. 15/2 is 7.5, so 1, 2, 3, 4, 5, 6, 7, 8. And so 7.5 would be about in between there. Now I'm going to shade between. And I'm also going to fill in the one on the right-hand side because it was the only one of the two that was equal. You could also put a soft bracket connected to a hard bracket like that, and that would be another way to graph that on a number line. Either way, just so I can tell the difference. Either it's open or closed circles, or it's a soft parenthesis and a hard bracket. It doesn't matter. They're both equivalent answers. And I don't have a preference as long as it's clear that you're not trying to fudge like your hard bracket, and you're like, oh no, I meant that to be a soft bracket. All right, be very clear about it.